Hey guys, welcome back to the third tutorial now, and in this one we will be covering a counter design. It'll be a fairly short tutorial, and then in the next few we will actually put this counter in the line drawer and finish the loop logic and then hook up a display. So to start off, let's show how this works. Okay, so the counter is everything over here, and this is just the clock generation and like control logic to control the counter and do what I want. So here is the branch address input. Here's the current output of the counter. Here we have up, down, enable branch. So what we can do is do this. We can set the branch address to 0, set the enable branch to true. We will tell it to count up by default. And then what we can do here is clock it like this. And now you can see what we have is a 3-tick clock, 1, 2, 3. This is 0 ticks here, so 3 ticks. And then what's going on is we put a 1-tick pulse into it. So we have a 1-tick clock, 1-tick pulse and a 3-tick loop here. So it's a 3-tick loop, it's 33% duty cycle, you can think of it like that. Anyway, so what we have going on now is we can pass this through, and the moment I do that, we get the branch address. So I can input whatever I want for the branch address and that will come through. So let's start it there instead. And then I can disable the branch, and the moment I disable the branch, it'll start counting up. Pretty nice, right? Okay, so now we can also start counting down instead. And you can notice that anywhere we are, we can switch between counting up and counting down. And it's just seamless. So that's the point of this. We needed an up-down counter that could branch, and we needed it to be fast. And I think this satisfies all of those requirements because it's 3 ticks, counts up and down. And yeah, branches. So let's show you how to build it. Alright guys, so what you see in front of me is a single slice of that counter that we had earlier. And I want to explain how it works before we actually go ahead and build this and stack it. So to start off, we have a data flip-flop where the output peg connected to the input of a inverter, and the output of the inverter connected to the data input of the data flip-flop. So every time the clock input comes in, it will toggle the state of the D flip-flop. The D flip-flop is then connected to an input of an XOR, and the other input of the XOR will be the control line to enable it to count up or down. So by default it's going to count up when this is not on, and when this is on, it will count down. What that does is it either inverts or non-inverts the output of this. So the other way you can do it is like swap, I guess in 0, I guess it could be even faster if you mux with one of these relays, either the inverted state or the non-inverted state, and swap between them. You could do that as well, I guess, and save a tick. But I'm okay with this for now. Anyway, this is then going to come into the enable pin of the relay, and this will enable or disable the clock passing through. So the clock comes into this one, and it will enable or disable it passing into the next, which if it does, then you will take that and tie it to the next one over there. Then what we have is the branch logic. So what we can do is, there will be, once we stack them all, we have to then flood these inputs here so that this comes to 0. And then what we can do is then enable the branch input to come through. And the moment we do that, it will actually put the data in here. So we're going to flood this without affecting the data output here, and that's why we did this a certain way, because if we connected it straight to there when we flood that, it would have flooded that as well, and it would screw with us. So now we're going to actually go ahead and build this and stack it. Okay, so to start off, like usual, we will start with a flat board and stack it out like that. We'll get a D flip-flop and an inverter, like this, and we will connect our loop. The next thing we can do is grab a mount, position it, press E, and you want to position it right on the edge as close to that sucker as you can, and that will stack. Don't worry about that. It looks like the default height is perfect for that, and we will set it there. I will move this over so we are straight on with that. Okay. So now what we want to do is set up the branch logic, or at least some of it. It's nice that that'll stack that close. If you want, you can stack. No, I guess you can't. That's why I did it like that. Okay. We'll do that. and then that's done. Now we want to set up this part of the logic where we can enable or disable the up-down part of the count, the up-down counting action, I guess I should say. So we want to get a peg or a mount there. We can press V on it and adjust it, and it looks like we want it probably the minimum size that it can be. Yeah, that is okay. Maybe one up from the minimum size. There, perfect. Okay. Now you can grab an XOR gate, and you can press F on the XOR gate to swap which side you want. I'm good with it on that side here, like that one is. The next thing we can do is line up another peg. Mount, I should say. Whoops. And I guess right there is perfect, yeah. And then we can put the relay working backwards on itself like that. Now, like I said, this should go to the control pin, but it can't reach. So how did I do that? We put another mount in. You know what? I think that I'm okay with it being there. Cool. And then now this one is a clock input. So the very last one. And this one we're going to want to make a little taller. Perfect. And the clock input comes into that right there. Then it will pass into there. Oh wait, no, sorry. It will also come into here. And then if it's allowed through, it will come into the next one, where then it would go, continue the pattern. This has to come to our control peg here. And that looks like an entire slice. Now we can readjust this and do our first stack. So you line it up. Remember, you're putting your cursor on that edge right there so it flips. You can press E a few times, and then I think it's T, yeah, and then E. And something isn't lining up here, so what isn't liking? And it's probably this right there, yes. Okay. Whoops. So we'll get rid of that and put this. I had it in the other one right there. Now it'll stack. There we go. Boom. So now what we want to do is we want to connect the branch control inputs together like that. And then we want to, we have this clock coming in. It has to connect to that there. And let's see, is there anything else that we have to connect? Yeah, we should connect these right here to control the up-down select. And that should probably be it for this part. So now, remember, if we pick up that board, it stacks weird, so we'll grab it by there. And we want 12 bits here. So what I'll do is we'll just connect the clock, then the control here, and that. Do it again. So now we have 5 bits. We want the clock input here, and then the control. Okay. Oops. Control G. This is now 9 bits. We want the clock. We want control. Now this is going to be 16 plus 1 is 17, and then we'll cut off what we don't need. Okay, so we want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, M, G, R. Okay, so we have our system here. Now we need to add one more feature. We need a mount, and what we need to do is we need to override all of those pegs, remember. So what we're going to do is go like this, put a buffer, connect the buffer, so when that's true it'll come here, and we want to control and hit all these pegs, and you'll see it's going to select them all, so press E and now it grabs every other one, and then hold Control and select that, and not all of them made it. So we will press R and make that a little taller. Try that again. And we can just do a test by hand to see where it... So we should move this up. That reach, that might actually do it. Yep, that'll do it. Okay. So now we hold Control. Press. Alright, we want to stop on that one. Press E. Nice. Now Control. Boom. Now we got them all. Okay. Now the input to the clock input is this. Branch control is this. And the up-down select is that. So now what we can do is build our control circuit for it. So we'll get rid of that. I will do this in a separate board. Now this is a one-tick monostable that was presented to me by a guy in the Logic World Discord named The Final. And at first I argued with him that it didn't work, and I feel like I always do, but you know, he was right, and this thing is beautiful. This is the best. Yeah, this is the easiest way to do it. So yeah, if you're looking for a way, boom, that's it, and you know, credit goes to him. So we'll pull that back a little bit more. Then what I want to do is have a control circuit that can. So we want another button. So this is going to be like start. This is going to be start clock, and this is going to be stop clock. Then we need a relay, and this will allow the clock through. So by default, the clock will go through. Now we want our 3 ticks of delay. So I'm gonna do it like this. You can do it however you want. Yeah, I guess we'll do it like that. And then we can have another control circuit that can pass the clock through, and that's the clock output. So we can have a clock enable. That. So this can go to the clock input. Okay, so now let's show you what we got going on here. So we got a way to set a clock, and then if we enable that, it'll go to the output, and then we can stop it by doing that. Cool, right? Now we need the controls for the up-down select, so I'll expand that out a little bit more, and we can make that the up-down select, and make that the branch control. And now, if you wanted, you can stack that onto there. Oh, there we go. God, this thing's picky. And then to reposition, you can hold Alt. Kind of do something like that. Beautiful. Okay, and then just pull that out one more. And I guess we'll leave it there, but name these. So this is going to be branch enable. This is going to be up, down, select. This is going to be stop, clock, oops. And then this is going to be start. And then don't forget this guy over here. Enable clock output. Okay, so we have everything we need. Now we can set up a branch address. So I would just do like a random address like I did before. Cool. Okay, now let's start the clock. We can enable it, and nothing is happening because we didn't connect this here. Okay, and now we can fix that pretty quick. You can also do a multi-select. I'm just going to do it by hand to make sure I don't screw it up. It's not many bits that have to be done. If you caught that while I was building it and saw that, kudos to you. Anyway, now we're looking at the output of the D flip-flop for the counter value. So if we want, whoops, let's stop the clock. set that to 0. We can start the clock again and just do a branch enable. And now we know there should be zeros in it. Huh. There are not zeros in it, and why is that? Oh, that is right. Okay, so when we do a branch enable, the other thing we have to do is then pass the clock to every single one of the inputs. So that's the other thing we have to do. You see how the clock only propagates to the first one? We have to do that now, and all the other slivs do that. Okay, so the easiest way to actually make it so that the clock will propagate through is enable all of these. And so we only want to enable all of these when we're doing the branch, which means boom. And now it updates. So now if we flip this true, you'll see that value goes into these registers. And if I turn that off, then zeros go in. And now we can stop the branch, stop the clock, and now put our output peg on. So the easiest way, in my opinion, is to probably put a mount here. Let's see if we can get it perfect. And then now we can put a board, press V, and then expand it both ways. And now we can just put one, oops, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That one doesn't make it, fucking course. Okay, cool. And then we can just bring them up just for ease of busing, just to have like our outputs over here. And then of course you can hook up displays or whatever you want. I'm going to leave them like this so that we can use it in our line drawer. Okay, so we will have to do a selection up to here. Okay, there we go. So now we have our counter output there. And now we can start the clock again and watch it go. Put in a branch address, say branch enable, boom, takes it, starts counting up from that. Say nope, instead we want to count down. And nope, instead like we want to just count down from the branch immediately like that, boom. And now here is your working counter. And hopefully this video is less than 15 minutes long. Hopefully. We'll see what happens when I put it together and I'm done editing. But if you made it this far and you got a working counter and you were able to follow this mayhem up to this point, well, congratulations. You are now ready to move on to the next point where we will actually connect this to the line drawer, which is over there. Anyway, thanks for watching. I hope to see you guys next time. Don't forget to like and subscribe. Bye.